Here in this question, it is told that there is point A that has the coordinates of -1, 6 and there is point B that has the coordinates of 7, 2. And in the first part of the question, I need to find the perpendicular bisector of AB and I need to give the answer in the form of y is equal to mx plus c. So this means that here I have a line. This over here is point A and this is point B. The coordinates of point A are -1, 6 and the coordinates of point B are 7, 2. And there is a perpendicular bisector to this line. Well, the perpendicular bisector passes through the midpoint. The midpoint would be somewhere over here. And the perpendicular bisector to this line would look something like this. And these two are intersecting at a 90-degree angle. In the first part of the question, I need to find the equation of the perpendicular bisector. So we know that we find the equation by using this formula of y minus y1 is equal to m times x minus x1. In order to use this formula, I need to find first the gradient of this perpendicular bisector and I need to know any one point on this line. Well, for the gradient, I can find the gradient of line AB and then use this relationship of the gradient of two perpendicular lines, their product is equal to -1. I can find the gradient of line AB using this formula of y2 minus y1 divided by x2 minus x1. If this is x1 y1 and this is x2 y2, the gradient would be equal to 2 minus 6 divided by 7 minus times -1. This would be equal to -4 upon 7 plus 1 is 8, which is equal to -1 upon 2. So the gradient of line AB is -1 upon 2. And solving this for M2 would give me the gradient of the perpendicular bisector as +2. So the gradient of this line is +2. Now let's find the point on the line. We know that this line passes through the midpoint. Let's calculate the midpoint of line AB. So midpoint of line AB would be equal to x1 plus x2 divided by 2, y1 plus y2 divided by 2. x1 is -1 and x2 is 7. So this would be -1 plus 7 divided by 2, 6 plus 2 divided by 2. -1 plus 7 is 6 and 6 divided by 2 is 3. So 3, and 6 plus 2 is 8, 8 divided by 2 is 4. So the midpoint has the coordinates of 3, 4. Now both the gradient and the point on the line are known. So I can find the equation now. The equation would be y minus, the y coordinate is 4, so y minus 4 is equal to m. The gradient of this line is 2, so 2 times x minus x1, so x minus 3. This would be y is equal to 2x minus 6 plus 4 and this would be y is equal to 2x minus 2. This is the equation of the perpendicular bisector. Now let's look at the second part of the question. Here it is told that a point C on the perpendicular bisector has the coordinates of P, Q and the distance OC is 2 units where O is the origin. So I need to sketch the origin over here somewhere. Well, I know that the coordinates of this point are -1, 6. So this point A would be on the negative x-axis or towards the left hand side of the y-axis. So I'll draw my y-axis over here. Let's say that this is my y-axis and this is my x-axis. This is the origin O and the origin has the coordinates of 0, 0. It is told that there is point C on the perpendicular bisector. So let's suppose that point C is somewhere over here and the distance OC is 2 units. So this distance over here is 2 units. The coordinates of point C are P and Q. So I'll write them here, the coordinates of point C, and I need to write two equations involving P and Q and then write the coordinates of the possible positions of C. So I need to write two equations involving P and Q and then find the values of P and Q. Well, I do know the equation of the perpendicular bisector, which is y is equal to 2x minus 2, and point C lies on the perpendicular bisector. So if I put the coordinates of point C in this equation should be satisfied. So putting the coordinates of point C in this equation would give me the y coordinate is q, so q is equal to 2 times the x coordinate of point C is p, so 2p minus 2. Let's say that this is the first equation, and the second piece of information that is given over here is that the distance OC is 2 units. I know that the formula of distance is square root of x2 minus x1 whole square plus y2 minus y1 whole square. If I name this coordinate as x1 y1 and this as x2 y2, I'll get the distance as square root of x2 minus x1, so p minus 0 whole square plus y2 minus y1, q minus 0 whole square. I know that the distance is 2 units, so in place of d I'll write 2, and this is equal to square root of p square plus q square. In order to remove this under root, I'll square both sides, and that would give me 2 square, which is 4, is equal to p square plus q square. This is my second equation. Now there's no need of the sketch, so I'll just erase this because I need some space to solve these two equations simultaneously. Equation 1 is q is equal to 2p minus 2, and equation 2 is 4 is equal to p square plus q square. Q is already a subject in the first equation, so I'll substitute equation 1 into equation 2, and I'll get 4 is equal to p square plus 2p minus 2 whole square. This would give me 4 is equal to p square plus, and expanding this using the formula of a plus b whole square, that is a square plus 2ab plus b square, and I'll get 2p whole square minus 2 times 2p times 2 plus 2 square, which is 4. Let's simplify this equation. 4 would be equal to p square plus 2p whole square is 4p square, so p square plus 4p square, and minus 2 times 2p would give me minus 4p, and minus 4p times 2 would give me minus 8p, and plus 4. P square plus 4p square would give me 5p square and minus 8p, and shifting this 4 on the other side would give me 4 minus 4 is equal to 0. These two cancel out and I'm left with 5p square minus 8p is equal to 0. Now this is a quadratic equation over here with no constant term, and to solve an equation like this we take the variable common. Here the variable is p, so if I take p common I'll get 5p minus 8 is equal to 0, and this gives me either the value of p as 0 or 5p minus 8 is equal to 0, and this gives me p as 8 upon 5. So either the value of p is 0 or either the value of p is 8 upon 5. Now let's find the corresponding values of q. I'll substitute this value of p in equation 1 because it's more simpler, and when p is equal to 0, q would be equal to 2 times 0 minus 2, that would give me q as minus 2. And when p is equal to 8 upon 5, I'll get q is equal to 2 times 8 upon 5 minus 2, and that gives me q as 6 upon 5. So this is the other value of q. So the possible positions of C could be either C can have the coordinates of 0, minus 2, or either C can have the coordinates of 8 upon 5, 6 upon 5. This is my answer.